Welcome back to the Professor Stu Boys channel. I'm Professor Victoria, and with me is Professor Corey, and we are continuing on with our equilibrium calculations series, and this is episode 5, and this is calculating new equilibrium concentrations. So this means that we are starting out with something that's already established in equilibrium, and we make a change, and we have to calculate once it reestablishes that new equilibrium, what are those concentrations? So here's our problem. Let's look at this.
Okay, so we have an equilibrium constant, that's the capital K, given for the reaction. The value is 10.5, and that's greater than 1, which means that this is a product-favored reaction. And we could even scaffold up our K expression if we wanted to. You could say it's the products over the reactants, and you can work on the ice table. I'll just talk this.
Okay.
So we would say K equals the equilibrium concentration of CH4 times the equilibrium concentration of CCl4, those are the products, over the reactant. Now, notice the reactant in this balanced equation is a coefficient of 2. So we're going to have to square the value of the equilibrium concentration in that expression. So, and there's another spot we're going to have to be careful with, when you have a balanced equation with some coefficients other than 1. Okay, so we have an equilibrium mixture of the three gases. We have the concentrations. And then it says, what will be the new concentrations if we add CCl4? We add some amount. Now notice they gave us the volume of the flask. It's 1 liter. And then they gave us molarities. And then they said we're adding 0.120 moles of the CCl4. Well, that's okay. Because it's going into 1 liter, all of these values are essentially moles. So we can add the 0.120 of the CCl4 to the initial, that's the 0.167, and we can get our new value. Now all of a sudden these concentrations, if we put these into the expression, would not equal 10.5. Now we're at the same temperature, so we're not at equilibrium anymore. Something's going to happen. There's going to be some shifting either left or right, and we'll get back to where our K does equal 10.5, and we're going to have new concentrations, and those we're going to see down there in the E from the ice table. So one approach to figuring out how the change is going to happen is to calculate a Q. Now a Q, it's the same formula as K, except these values are not equilibrium concentrations. And we just said that these initials are no longer equilibrium concentrations. So we're going to put our products over our reactants. And notice we had to square that reactant concentration because the balanced equation has the coefficient of 2. Solving for Q, we get 18. This is greater than K. So that's too large right now. And since this is products over reactants, it's telling us that we have too many products over our reactants. It's making this number too big. The products are in the numerator. So this is going to shift to the left to make a smaller number. So if Q is greater than K, shift left. If Q is less than K, shift right. That tells us our change. If we're going to shift to the left, that means that the products are going to go down and the reactants are going to go up. Now another way we could have done this, we didn't even need to use the Q. If you looked at this problem and just understood that, okay, we're adding product to an equilibrium, you can see that, Le Chatelier's principle says that if we stress an equilibrium, it's going to shift to relieve that stress. Well, the stress was adding product. So the shift is going to be to reduce that amount of product, shift left. That makes sense as well. So you don't have to calculate a Q, but if you like to calculate a Q, then definitely do that.
So since we weren't provided any equilibrium concentrations, we are going to express our equilibrium concentrations in terms of X. So this is what we have here. And since we have K, we can put these numbers back into our K expression and solve for X. So our K is 10.5.
10.5.
Equals products over reactants. So our products are 0.167 minus x, oops, and 0.287 minus x divided by 5.16 times 10 to the minus 2 plus 2x squared.
Okay, special attention to that squared. The reason that's squared is because of the coefficient in the balanced equation. The coefficient of 2, that means we're going to raise that to the power of the coefficient. So we're going to have to square that value. Now you can see up at the top, it's pretty easy to see that, okay, we're going to use the FOIL method. Well, same thing down at the bottom. 5.16 times 10 to the negative 2 plus 2x squared is the same thing as multiplying that by itself. So we're going to use the FOIL for both the numerator and the denominator. And this is it's a cumbersome algebra problem.
It sure is, and which is why we are doing it out for you. So you can watch, follow along as we go nice and slow, and you can follow it, and you can speed us up if we need to, and slow us down when you need to. So let's do the numerator first. So we're going to FOIL. We have to FOIL this top because we have two terms here and then in this one, and we have two over here. So we have to do inners, outers, and so basically we're doing kind of like distributive property in both directions, right?
So FOIL, the F in FOIL is the first. So the first number in both of those is 0.167 times 0.287, and that's going to equal 0.04793. Now we're going to do the outers. So if we looked at the thing as a whole, our outers would be 0.167 times negative x. So that's negative 0.167x. Our inners, 0.287 times negative x. And then the last, negative x times negative x is a positive x squared. We can combine those x's. We'll do that in the next step. Let's FOIL the bottom.
So here we're doing these FOILs. So first gives us 0.002663. And then we're doing these inners. So that's a plus.
Outers. Do the outers first.
Oh,
They're the
outers.
same.
Yeah,
They're the same,
yeah,
but
FOIL though.
Yeah.
That's true. So this one times that one is 0.1032x. And the inners are the same. 2x times that number, so plus 0.1032x. And 2x times 2x is a positive 4x squared.
all right. So now I think we should combine the x's in both the numerator and the denominator and maybe just rewrite this. So what we're going to do is, because those are both x terms, we can add those together. So if I add 0.1032 plus 0.1032, I get 0.2064x. And then up on the top, I've got two negative numbers that I can add together. So I've got the negative 0.167 and the 0.287. If I add those together, I get negative 0.454x.
Okay.
All right.
So we want to bring all of this. Okay, we're going to multiply both sides by this. And if we multiply the right-hand side by it, it will just cancel. So I'm going to multiply it here by the left. So I'm just going to rewrite it because that kind of helps.
Yeah, so we're going to take that 10.5 and distribute it amongst all those three expressions. And that'll just be equal to what's in the numerator.
Okay.
So 10.5 times 0.002663 is equal to 0.02796. Next, I'm going to multiply it by the 0.2064x, and I get 2.16 2.72x. Lastly, 10.5 times 4x squared, 42x squared, equals what we have on the right. And we're just going to pick one side and set it equal to 0.
And that's because we have a squared term, just a plain x term, and then just a number term. And whenever we have that, we need to use the quadratic formula. And we have to set everything equal to 0 so we can figure out what our a, b, and c is. So we're going to bring everything over. We're going to bring it over to the right or the left. What do we?
We're going to set the 0 on the right. So I'm going to subtract 0.04793. And now when we do addition and subtraction, we have to have like terms, so we have to subtract that from the number with no x. And we get negative 0.01997. So my x term now...
I'm going to change colors just so I can do this all together. So this is positive 0. I'm going to add that to my x term. Go back to black for down here. And what do I get for that?
I get positive 2.6212x.
Great.
And that x squared on the right is really 1x squared. So I'm going to subtract 1x squared from 42x squared, and that leaves me with 41x squared. That's equal to 0. I have an a value is 41. My b value is 2.6212, and my c value is negative 0.01997. If I put this into a quadratic equation solver, or if I solved it by hand, or I used a graphing calculator, I'm going to get two roots. The first one, negative 0.0708. The second one is 0.00688. One of these roots will not make sense. And if we go back and look at our ICE table, we can see that a negative value for x really doesn't make sense. We can't subtract an amount or add a negative amount. So it's probably safe to say if you get a negative value for your root when you're doing these problems,
can't have a negative molarity.
That's going to be the one that doesn't make sense. So this is our x value. Our x value is 0.00688, and I can simply go back to my equilibrium, and I can put that value in for x, and I can get my equilibrium concentrations. Do you want to just write them in the little boxes?
Yeah. Okay. So x, I'm just going to put x equals 0.00688 molar. And if we put that number in for x, and just take the initial value and subtract, or take the initial value and plus 2 times it, what do we get for our answers?
Okay, so the CH2Cl2, 0.0654. The CH4, 0.160. The CCl4, 0.280.
And there you have it.
Units are in molarity.
That was a bit of a bear of a problem, but it's just algebra. It's just math.
Now I think if you scroll, I can't remember which direction, up or down,
okay,
you'll have another problem. And this is the one. This is a problem that we made just for you to try to practice using all the skills that we've taught you in the previous videos. So some things to point out. There is a solid in this expression.
So K is just our products. And our reactants are left out because it's a solid. So that is your K expression. And we're going to give you your answers. And the NH3 is, do you want to give them a moment to pause the video if you'd like to pause the video?
You got 20 seconds.
20 seconds. Uh-oh. So this answer is 1.11 times 10 to the minus 2. This answer is 6.29 times 10 to the minus 3. If you get kind of close to that, it's probably a rounding error, and that's fine. Thanks for joining us. We'll have more episodes for equilibrium calculations coming soon. Bye-bye.